Nobody hears anything through a microphone though, because like only your voice shows up with the subtitles for the most part.
No, it's because it's coming through my computer.
Oh, is it?
Yeah, it can't see that.
Alright, so I usually do announcements around this time, but nothing really to announce.
I know, it's kind of distracting, isn't it?
Yeah, a little bit. So yeah, tonight we have Lloyd. He's going to be speaking about the Go support for Windows. He's a very knowledgeable person, especially when it comes to Windows. So everyone welcome Mike.
Yay!
Hey! Okay, so before we start with formal introductions, I'm going to lay this out on the table right now, and I wanted to wait till we were on the stream so that everybody could be aware. I did not actually lay out the formatting for this presentation. I went through and it was all white backgrounds and everything like that, and then PowerPoint was like, hey, would you like design ideas? I was like, okay, sure, let's see how this plays out. So every little aspect of the design that is not text was totally auto-generated by PowerPoint. So I just wanted to see how it tested with other people, because I was like, oh, useful. So for introductions, my name is Mike Lloyd. I am currently a Principal Innovation Specialist at the General Services Administration, which is a subset of the overarching federal government. No, we are not spying on you, and no, I'm not watching your every move. I help run the cloud.gov platform. So today's talk is really about kind of Go for Windows, and to kind of look at like what we're going to talk about. We want to talk about, or I want to talk a little about the state of where Go for Windows really is, kind of what that looks like. And then as soon as I explain what that state is, your first question will be, well, why the hell do I want to use this? And then I will explain why. And then I'll kind of dive into some of the internal aspects of Windows to really set the stage for why you should actually care about Go on Windows. But in order to do that, I need to dive a little bit into Windows, explain some constructs. You're going to look at this and go either WTF or this is really interesting. I know they're really distracting, aren't they?
Oh no, it went off.
Yeah.
What?
Oh.
Well, that's unfortunate.
We'll figure it out.
We'll figure it out.
Party foul.
Party foul.
Sorry, streaming folks. Or can streaming folks still see it?
They can probably still see
Streamer
it.
folks can still see it. What's going on here?
Here, I think it's something to do with this.
Did you
Yeah.
touch something wrong?
I think I did.
I'm messing around with the TV.
There you go.
Hey, there we go.
You were just making sure you guys were listening.
Yeah, man, totally listening. So we'll dive into Windows. It'll be a refresher for those that are familiar with Windows and a learning experience for those that are not. I'm curious to hear your responses to it. And then we'll talk a little bit about how it works, like how Go on Windows actually works. A lot of things I'll explain on this one. We'll talk a little bit about what's currently in flight for Go for Windows. And then we'll kind of talk about some future-looking thoughts, where directions that we kind of are interested in potentially taking it, but may not. Nobody really knows. So let's talk about the state for Windows. It works, right? It's great. It's fantastic. So it does actually work. Go for Windows does compile. Everybody's pretty well aware of this at this point in time. It does exactly what you think it would do. And there is support for x86, AMD 64, and ARM 64. Believe it or not, Microsoft actually added ARM 64 support. Just came out of nowhere with that PR, like, hey, we would like to add AMD 64 support. Everybody was like, okay, why not? Sure. So that's how that got there. It was one PR, it had like 10 changes, and that was it. Totally minor. But that's mostly because Windows handles that as opposed to anything else. All right. So one of the things that's really interesting is there is no native CGO support for Windows. If you do want CGO on Windows, like for example, some of the Docker shim stuff, as well as some of the WinC stuff from the Cloud Foundry ecosystem and Kubernetes and stuff like that, the way it works is basically they use what's called either MSVC or Cygwin, which is kind of like a Linux toolkit for Windows before like the Windows subsystem for Linux came around, to go through and use the GCC compiler to go through and generate the necessary assembly for the C calls. It's not great. It's not ideal. There is a project called GoCV that runs on Windows. They currently use, I think it's MSys2 or Git Bash or one of the tools to go through and compile their CGO code to a binary for Windows. So it's not great. It's not ideal. It works. It gets the job done, but it sucks. Like, that's the general premise. Is it just kind of sucks. However, the standard library support sucks even more. So in Windows, there are a bunch of constructs, which I'll get into in a little bit. There's COM, CLR, and UWP. So there's no support for COM, there's no support for the CLR, and then there's no support for UWP. basically what this means is you can write Go for Windows, but you can't actually do anything really interesting with Windows. So like for example, Go on Linux or Go on OS X, Mac OS, whatever the hell they call it these days. You can build a really interesting graphical tool. All the toolkits are there, like the CGO support's there, like all the libraries are there. You can be really successful with Go on Linux or Go on Mac for like desktop applications. Not really the same case on Windows. There is a project out there called Go Walk, which is designed to help with Go for Windows, like higher order applications. I've looked at it, I've played with it. No offense to the maintainers, it's a hassle. It's not their fault. It's just the lack of support for Windows and Go is just terrible. They have done the best they can, and the effort that they've given is substantial. So it's nothing negative on them. It's just how things are. And so without some of that kind of more Windows-specific support, like it's really hard to build higher order like desktop applications or higher order server applications or other things that are a little more Windows-specific. So then the next big question basically is going to be, well, if it sucks this hard, like why would you actually use Go for Windows, especially for like desktop style programming? Like what is the benefit? That's why. The world runs on Windows. Like whether you agree with it or not, whether you are happy with it or not, from a desktop standpoint, the world runs on Windows. Obviously in the server market, things are a little bit different. Generally it's a little more Linux with a little less Windows, but that's only for web servers. Nobody really goes out and polls all the other servers that are running. And generally most of those are Windows because Windows does all the internal administrative things for companies that Linux generally doesn't do, such as identity management and email management and all these other things that Microsoft has spent the last 40 years doing. And if you, just in case somebody didn't believe me or if there were questions or whatever this is, so this I pulled from StatCounter last night. It is the desktop and tablet operating system market share worldwide over the last year from March 2018 to March 2019. Windows owns over 70% of the desktop market share, right? And this goes back to the, hey, Linux is great, but like the year of the Linux desktop will never come. Like that is the reality of it. Like Windows owns that market, OS X is a close second, and then there's like one or two little things that are coming up. But the reality is it's Windows, right? So if there's not great support for Go on Windows, but Windows is the primary desktop application. Like, what are the benefits? Like, why would we want to do this? And in order to do that, I think it's a little important to dive into some of the internal constructs of Windows. So I think it's, kind of important to kind of market Windows a little bit. We'll talk a little bit about it now. What's really important to know is those of us that really know Windows understand that the two things that I'm going to talk about are super contentious. And the reason they're super contentious is because nobody can agree on whether they are really good things or really bad things. There's really no middle ground on those two constructs. And I'll get into them in a little bit. But that's the general consensus, is those of us that know Windows either really enjoy it or really hate it. So Windows as an operating system had its first release on November 23rd, 1985. Before I was even around, Windows is older than I am. These days, Windows is available in 138 different languages. And that's not just like, oh, hey, like the core aspects of Windows are available in 138 languages. That is every single aspect of the UI is in that language, 130 different languages. In fact, the localization team at Microsoft is as big, if not bigger than Pivotal as a company. So it's massive. And they're focused purely on localization. It's impressive, really. Windows is also truly multi-platform. There is Windows IoT, so you can run Windows on a Raspberry Pi. It's not the desktop experience like you think of it. It's generally designed for running smaller applications, but it does do what you think it does. There's Windows for mobile. You can actually, I've seen a video of somebody installing Windows 10 on a OnePlus 6T. Now, it booted and crashed on the login screen, but the fact that they got it to boot was impressive. There was also the Windows Phone, which everybody knows was a complete and total failure. Thank you, Steve Ballmer, for ruining that for us. Then there's obviously Windows Desktop and Windows Server. And then there's other flavors of Windows that I'm not talking about because they're generally tooling or other things that really aren't there. There's also Windows Embedded, which is a subset of Windows Server, and so on and so forth. For example, the Xbox is actually Windows, believe it or not. It is Windows under the hood. It uses the exact same kernel as my Surface Book and the Windows Server VMs up in the cloud. So there is Windows everywhere. All right. So these are the two kind of primary internal aspects of Windows that most folks who really know Windows development either love or hate. The first is COM and the other is what's called OLE, or OLE. Most people call it OLE. So COM stands for Component Object Model, and COM is a platform-independent, distributed, and object-oriented binary interface for Windows. So in Linux, generally everything is a file descriptor of some kind. You work with everything as a file. That's not how things work in Windows. In Windows, everything is an object. And an object in the kind of like your classical programming construct. So for example, if I wanted to work with the microphone, there is a higher order microphone object, and then if I wanted to work with the stream, there is a stream object, and then if I wanted to get bits and pieces of that stream object, I would say get at this point, so on and so forth. If I wanted to work with the mouse, there is a higher order mouse object, which then has XYZ coordinates for the location of the pointer of the mouse, and so on and so forth. And as part of that, Microsoft wanted to make a way that application developers could go through and let not only applications interface natively with other applications, but they wanted it to be totally independent of whatever Windows is doing under the hood. So they came up with COM. And COM has existed since, I think, Windows NT, which is early mid-90s. And it's gone through a couple like minor iterations, but for the most part, COM is what you think it is. It still exists today. PowerPoint uses COM. Word uses COM. Most really good Windows applications use COM at some point or another. What's really useful about COM is that because it's generally a binary interface, it's language agnostic, and it's not actually a language, it's a standard. It is a way of describing something. So let's say that I was going to write like a notepad application, right? And I wanted to be able to expose controls for my application to another application. Maybe it's for like accessibility, because I want like the narrator to be able to hook into my application to read like a menu. Or maybe it's because I want to be able to control my text editor from a different program. Maybe I want to like write something real quick and then save the file, or whatever that is, right? But like full application automation, like COM allows me to do that. I could create a COM object that describes that interface for my application, and then another application somewhere else can use it. So it's a very, very powerful way of describing low-level application or hardware objects to other applications. Larry Osterman, who is like an amazing Windows kernel developer, he gave a talk on Twitter recently. I think it's called a 2-minute story on COM and the value of COM. Unfortunately, I don't have it linked here. It'd be worth showing. But it's a very interesting watch. It's 2 minutes, totally worth it. It kind of gives like a history of COM and like why Microsoft believes it was important. And then there's OLE, which is object linking and embedding. OLE is basically built a little bit on top of COM objects, but it's designed to kind of share COM objects between. Generally, you can think of OLE kind of like a message bus. It's not really a message bus, but what you can do is you can tell the OLE provider, say, hey, go do this thing, and then the OLE provider will take that, and then it'll go work with the COM object that it needs to go talk to, and then do whatever it's going to do. It's kind of similar to signals in like Linux, how you have SIGINT, SIGKILL, et cetera, but it's designed for like COM objects and application objects. So it's a much higher order aspect. I would say like the next closest thing to OLE would be some of the stuff that like systemd or launchd do internally with like how they signal applications to do things, how you can use application automation, stuff like that. So I'd say that's probably the next closest thing. It's just not quite as powerful as OLE. One of the things that's really useful about OLE is you can add higher order features and functionality on top of it, such as drag and drop. So one of the things that's really useful in Windows is, let's say you have like 2 file explorers open, you want to drag something from one folder location to another folder location. OLE is the underlying technology that actually lets that happen, because what it does is it creates a COM object, associates it with your mouse object, and then when you move to the next folder object and drop it, it says, oh, okay, I understand what I'm supposed to do. From this COM object needs to go to this COM object, Olay, please transfer it for me, do what you have to do. Which is actually part of the reason why if you drag and drop something in Windows, it's slower than if you did like a file line transfer or like a CLI transfer. So like if you did CP on the command line, that's actually faster than dragging and dropping because it doesn't create a bunch of COM objects, it doesn't do a whole bunch of other stuff. So nifty little kind of nuanced thing there. So generally in Windows land, COM and Olay are like, you know, the bee's knees, right? Like that's, people either love it, they hate it. They, you know, if they love it, they'll write applications that have so many different types of interfaces and for controls and stuff like that, or they absolutely hate it and they avoid it at all costs. There's really no middle ground that I've ever seen. So let's talk a little bit about like the value of COM, right? Like why would I want to use COM? Like what is the reason for using COM? I would want to use COM if I need a binary standard for function calls between components. So let's say that I have Go application A and Go application B. They don't talk to each other at all. They don't know anything about each other other than, hey, they're allowed to pass this message of this format. They could say, hey, create a COM object that meets this that satisfies this interface, and then here, I'm going to make it available. And then Go B could say, hey, I need a COM object that satisfies that interface, and then it can query Olay, and Olay will say, oh yeah, I know somebody that does that, and then it can interface with that COM object. And I might be explaining this a little bit wrong. It's been a long time since I've worked with them like that. So please forgive me. You would also use COM if you do want to leverage like strongly typed groupings of functions, but from an interface standpoint. So think of it in Go kind of like, hey, I have an interface definition, but none of your Go code actually goes through and implements that interface. COM would implement that interface, or some other application would implement that interface, then you can just call into it. Think of it kind of almost like inter-process RPC, but not quite. You know, you also want to work with like polymorphism, right? So let's say that you have an interface that is a subset of, or interface B that's a subset of interface A, or an extension, then you can leverage COM's polymorphism to go through and kind of implement that. You know, COM objects are also uniquely identified, so if I start Go application A with a COM interface, and I kill it and I restart it, it's going to come up with a totally unique COM interface that's separate from the last one, or if I have two instances, totally different. It's very much like class identity, or it's very much like identity in like your standard OHU constructs. And then you can also use COM as like a component loader as well. You can say, hey, initialize these things, do it in this order, like it's very powerful. What's really useful about COM is because it's a standard and not like an inherent language, there's total interoperability between languages. I could use, if Go had COM support, I could use Go to talk to and control a Java application or a .NET application or a C++ application or any combination or permutation of that, because COM is doing all of the interfaces on my behalf as opposed to the actual language, right? So for example, if I wanted to have a Go application talk natively to a Java application on Windows, I wouldn't need gRPC, I wouldn't need REST, I wouldn't need a web server, sockets, I wouldn't need anything. I would just need a COM object definition and then a way to go through and interface with it. That is it. And it all happens local. What's really useful is COM also has formal support for remote objects. So in Windows, you have something what's called WSMan, which is your Windows Server kind of configuration interface. And it's all COM and Olay under the hood. What it allows me to do is, let's say that I were to have my local server, and I was like, oh, hey, I need to change this remote server's configuration. It doesn't have SSH. I don't really care about that. Like, I just want to change the configuration. I can say, hey, I want to work with this local COM object, or I want to work with this remote COM object as if it was a local COM object. Please connect, do this change, and then tell me when it's done. And then just like that, it's done. So it's kind of, think of it kind of like SSH, but instead of actually just a full session with that computer, you're operating on the internal objects of that operating system. So it would, like, if you were to kind of translate this to like Linux land or something like that, what you would see is basically like, hey, I want to interact with that remote Linux server's systemd, but I don't want to actually get a terminal session. I don't want to do anything other than send it API calls. Please do that for me. That's very much what COM is able to do on the Windows side of things. So it's very, very, very powerful. Thankfully, it's locked behind years of lessons of learned with authentication providers and things like that. So there's all, tons of support for making sure that, bad people don't do bad things, but like every system, it's prone to not well experienced operators. All right, so who is ready to learn how Go on Windows works? This is going to blow your mind because it is so convoluted. It is not fun. All right, so at a very, very high level, the general premise is Go build generates what's called a Windows PE. And a PE is a portable executable. It is a file format very similar to ELF and Dwarf in the things that it accomplishes. The actual file format is called COF. It's COF in that they still use the name COF. It's really nothing like the original at this point in time just because it's so old. Originally, the COF file format came from Unix sysv. So Microsoft's file format is very compatible in that regard, at least from an executable standpoint. So what happens is once Go build generates a Windows PE or .exe, depending on how you want to call it, when you go to execute it, it generates a syscall like everything does. The syscalls are really not that great. Performance really sucks. The usability of the syscalls is not great. A lot of that stems from the fact that Windows leverages C++ extensively. There's not like a libc for Windows. It's windows.h, and then that's kind of like all the important things, and it's all C++. And the challenge with that is Go doesn't like C++. Go likes C because there's no classes. So if you want to do anything, you have to write an extern wrapper for a C++ class in C, and then you have to call it in CGO if you want to use it. Yeah, now you see why it sucks.
Well, you started this talk by saying CGO support kind of sucks.
I did, so I set the expectations. And then on top of that, there's horrible type management. So to make it a little bit easier on developers, let me preface the horrible type management. Go's type management is fine, Windows type management is fine, but when you try to mix the two, it's like trying to mix oil and water. So the reason is because Go's type management is great. A uint is a uint, an int is an int64, depending on which system you're on. But for the most part, like it's pretty straightforward, pretty simple. You have your standard programming types. Windows does, but they also call them different things, and they use aliases extensively. For example, dword. That is an unsigned integer. But a dword is really useful because it's an alias for something else. And so Windows uses type aliases extensively in not only all their documentation, but in all their interfaces. And generally it's just a typecast, like it's not a really hard conversion or anything like that, or you'll have like the types that you need ahead of time. But when you try and like work with that in Go, it sucks really bad. You have to know, like if you're writing like raw Go for Windows, you have to know, and you want to make like syscalls, you have to know that a dword is a uint. And if you don't know that a dword is a uint, you're not going to have a good time. For example, LP void. In Windows land, an LP void stands for long pointer void. C and C++ actually know what the hell to do with a long pointer void, which really is just kind of nothing. It's just a memory allocation so that you can go work in that memory space, if you need it. Go doesn't have that construct. And so what is an LP void? Well, LP void is also a uint, but it's a pointer to a uint. Okay. Now you look at this like, what the hell do I do with this? How do I work with an LP void? Like, what is going on here? And so you get into this really frustrating situation where you're like, why do I hate my life so much, basically? And it's not a good time. And there's like some very, very, very basic support for like Windows types in the xsyscalls Windows library, but it's not great, like at all. Like, let's be real here, it's not great. So you have a bad time. So moving on past syscalls, what happens to the syscall, once it's made, the Go runtime will end up ultimately calling CGO call, which the compiler will convert into assembly, and then it calls the Windows C ABI. It's my understanding that Linux will natively call the actual C interface. Correct me if I'm wrong. But in Windows land, that is not the case. It makes absolutely no calls into any C interfaces, and it calls natively into Windows C ABI. It's well documented, like how Windows ABI works. It's just not that great. And we will explain even why here in a bit. All right, so I do have some example code, which I will throw up on the spare monitor. Could you do me a favor and turn that around though, so I will be able to see it?
What's it? This?
Did it pop up?
This thing?
Which one is it? Let's see.
You just want to see the stream or?
No, I want to see whatever it's going to open up. Come on.
Should be behind you too, that's what the stream is seeing.
Yeah, it's the same
Okay,
thing.
gotcha. So let's do. So basically, here's the way it works. What this sample code does when he distributes the PowerPoint presentation, you guys will have access to all of this, so don't really worry about finding it. What this really is an example of how to create a background process in Windows. Basically, what I'd like to do is start Notepad and then manage the lifecycle of Notepad. Right, pretty straightforward. But what I do is I go through and I kind of demonstrate, like, here's what some of the types are. For example, LP Void, UN16, my bad. So, oh yeah, sorry, my bad. Come on. There we go. So I kind of demonstrate like the type system, like what that looks like. And then I kind of demonstrate like how to leverage it and what that looks like. And then we come down over here. Oh, well, hey, if I want to create a background process, like what does that look like? Well, here's kind of how you go through and do it. That doesn't look like very good code. And the reason it doesn't look like very good code is because in Windows land, everything is C++ and everything uses pointers. Because C++ does not support multiple return types. Well, actually it does now, but the Windows API does not support multiple return types because when they wrote a lot of these APIs, there was no support for multiple return types. So guess what? Every parameter is a pointer. So yeah, it really sucks and it's not great and it's not fun. And so, when we start to look at, okay, well, hey, let's go ahead and actually create a process. Oh, syscall 12. What is this? Like, what is this? Like, how? Why? Oh my God, what are these? What is this doing? This makes no sense. Oh God, make it stop. Right, look, we have 2 zeros at the end. Does anybody actually know what those do? Because I actually have no idea what they do. That's a lie. I know exactly what they do. But the point is, like, I need to call a function that has 10 arguments, and the only way to call it is with syscall 12. I have to zero out the last 2 arguments because, oh hey, I don't actually need them. Right. So this is where Windows really start, like the Windows syscall interfaces and where Go for Windows is like really falls apart. It's really not fun. Get last error is basically, so what will happen is like Windows will, for a lot of functions, Windows will go trying to execute the function, but it won't return an error type because it needs to return the actual type of whatever it's trying to do. And so it'll throw an error into the error queue and then you call get last error to go and return that. Now, that's a shot on Windows, like that kind of sucks, and I'm more than happy to say that Windows could have done better, but I get it. So, then we have to go here and do some error typing and stuff like that. The reason it looks really bad is because I ripped all of this out of the standard library for demonstration. You could literally copy this code, and then it will compile and do exactly what you think it's going to do. So, so that's fun. All right, back to where we were. So what I wanted to show is like an example of basically kind of how it works, like how much it sucks. You can see it, and then now what kind of actually do like a dive in. Are you gonna stop? There we go. Perfect. And where did the subtitles go? Haha. Cool. So I am using a reference of a library that I have written, which will kind of help make the writing Windows code for Go a little bit better. So basically what I did was I extracted every aspect of the Go runtime that had anything to do with interfacing with Windows, including assembly and a whole bunch of other things. And what I did was I wrapped it up in a package and I said, okay, I want somebody who wants to write Go for Windows to have a good time. I want it to feel like they're writing Go. I want it to feel like they're actually using it on Windows. So proper type systems, things are located in the right place. There's actual syscalls in the library that are like more than just like the 3 functions that the standard library supports and things like that. And so that's kind of what this is and why it kind of gets a little bit into it. But the general premise is the same. There's like 1 or 2 things that you would pull out. But for the most part, this is how it works. So let's say that I wanted to get the current process ID or get the current process object for the process that I'm running. In this case, it would just be the Go binary that we're running, right? Go runtime. So I'm going to call get current process for the local process handle. And a process handle is basically a uint to the object that represents that process. So we're going to call it. That's the first thing that we're going to do. That's all we care about is getting this handle back. What's going to happen next is getCurrentProcess is going to load the DLL that whole dynamic linked library, which is kind of like Windows library versions, kind of like dynamic libraries in Mac. Is going to load the DLL into memory via what's called proc getCurrent process.adder. And so what this function does is this function is the address of the DLL. It is not loading the DLL. The DLL isn't like loaded in memory. It's literally just the virtual address of this DLL, and it does nothing at this point. So what's going to happen is in the process of going to load the location of this function, what's going to happen is it's going to instantiate what's called a new proc. And this is where shit gets really weird. So new proc is basically what's going to happen is it's going to load up new lazy system DLL. And so as we can see, all we want to do is get the current process handle, and we're already four functions deep. We haven't even actually done anything yet. So what this does is it takes the new lazy system DLL, takes the DLL that we need, and it will go through and load it into memory. It will take that file and it will open it and it will load it, and it will through a function called load library x, which we can see here on the end. And what's going to happen is it's going to basically load library x is a function of the Windows API, which will go through and search through that DLL and all of its functions and return that function's virtual address. I know, right? Yeah, trust me. This took a lot of debugging to figure out like what specifically it was doing. So basically at this point in time, all that has happened across this whole slide, we don't even have the process handle yet. All we have done is load the virtual function's location in memory. It's just a hex address. So when we call into the Windows CABI, we can say, well, I need this function at this address, give it to me. And then Windows will return it. That's all we have done for this. And we've already gone through like 7 different steps. So we haven't even called anything yet. So basically, once we have loaded the virtual address, or the function's virtual address, now we are ready to actually go through and start figuring out how to make the syscall. So what's going to happen is when the Go runtime generates the assembly, it's got to figure out which syscall function to call, and it's basically going to call syscall. I think it's like 1 through 13. I think is how many there are, or something like that. And it's going to make the determination based on the amount of arguments that's passed to it when it gets there. And then for anything that's above and beyond, so let's say that the function has four arguments that you would call syscall.syscall 6, and then it will just send zeros for the last 2 arguments, as we saw earlier. At this point in time, what's going to happen is the runtime is going to make a cgo call, which I explained a little bit earlier, and then it will call into the Windows CABI at that function's virtual address with those parameters, and then at that point in time, Windows will go through and execute it, and the stack will start to unwind. Now, if you're wondering how big is the stack just to make this one function call, the answer is generally somewhere between about 8 and 13 functions deep. It is huge to make one syscall. And that is why Go for Windows has horrible performance comparatively. It is not great. It is not fun. Yeah, welcome to the world of Go for Windows. That is just to make a syscall. That's not building a higher order like graphical application. That's literally like just get my current process handle. Now when you look at how complicated this is, now try and go build a higher order desktop application for Windows. Try and build something with a graphical interface. You know what everybody else uses? Electron. Keybase, the #1 provider of graphical interfaces with Go for desktop applications, Electron. Because even they will not try to write a native Windows application. Like, that's how bad it is. They have had this, Keybase has had the same Go for Windows job description up for like 6 months. That's how much they're hurting for somebody who knows Go and Windows, because nobody wants to learn it because Windows isn't the cool thing. Well, it's coming back, but most people think it's not the cool thing. And on top of that, developing Go for Windows really does suck from time to time. especially when you want to go do something that's not a part of the Go standard library. So, yeah, it's down a rabbit hole. It's not great. It's not fun, but welcome to Go on Windows.
I have a question.
Of course.
So there's a lot of complexity involved in just doing something as simple as doing this call to get the process ID.
Sure.
Is that an attribute of Go's implementation of support for Windows, or is it an attribute of the inherent complexities of writing software on Windows? Because I'm very foreign to Windows. So.
It is an inherent complexity of the way that Go for Windows works, like the implementation within Go itself.
I guess what I'm saying is, could it have been implemented better, and is it something that we can iterate towards improving?
At the time, it could not have been implemented better. So the only reason Go for Windows actually does anything, like that it is even a reality, is because of a guy named Alex Brainman. I've never met him in person. I don't know anybody that's ever met him in person. He doesn't have any type of like social media profiles. He is literally just a GitHub handle, and that is it. I've never met anybody that knows any more about him than that. Alex Brainman wrote the initial like implementation for Go on Windows. Like, and all of what I described is all a brainchild of his, and why that works. Looking back, that's probably the best way to go about it, because it is the absolute most supportable, easiest way to go. That's how you can get like all the low-hanging fruit, right? And then a lot of it's because like Go leverages CGO, not C++ Go. There is no like C++ support of any kind, and trying to figure out how to like have that interface just wasn't worth it. Go didn't want to go in that direction, and so he's like, we're just going to load up the virtual functions address. Microsoft team, like the Microsoft Windows team, like totally supports that. This is a supported way to go, so it's like, well, why not, right? Like, it wasn't bad. Now, obviously, because hindsight is 20/20, we can look at it with different lens. Now, there's totally different ways that we could go about this in a much more effective and efficient way, but it doesn't necessarily mean that Go is going to want to go that way, or that it's going to be the best way to go, because it's going to change. Just because it's much more complicated. And I don't have all the answers, and I shouldn't have all the answers, but I definitely think that there are things that we could do better, such as let's put it this way, we could probably improve performance drastically if we loaded all of the necessary DLLs at instantiation. So one of the things that's really interesting about .NET is for any of the libraries that you're like included with your application, generally the runtime is going to go through and it's going to have a component loader, and it'll say, do we need this now, or do I need this like way later? And if it doesn't need it now, it's not going to load it, but it'll still have it like kind of ready to go, and it's kind of in the order of things to be loaded. Go doesn't really have like a component loader in that aspect. Like, once the runtime instantiates, like, you're ready to go. Like, it doesn't allocate anything until it gets there. As part of that, if we could go through and as part of the like instantiation, go ahead and go through and instantiate all the DLL's function addresses, you get massive improvements right off the bat, because then you don't have to go through and like load it every time. Because what's going to happen is, let's say you have to make like a bunch of syscalls, but they're just far enough apart that the garbage collector is going to run. So what's going to happen is, you're going to make the first one. It's going to go through the whole process of loading that DLL and then making the call, and then the garbage collector will run, and then it'll get rid of that whole function's virtual address. And the next time you go to call into it, which is probably shortly after the garbage collector runs, oh hey, now we have to do this whole process again. So having a way to hold those in memory would be great. There's the project that I talked about last time at the meetup, Big Cache. They actually, or we, I guess, because I'm part of that team, we have an optimization in the internal cache implementation that became present in Go 1.4, which basically means if you hold everything in memory as either a uint32 or a uint64 and no pointers to it, it will not get garbage collected. So basically, if you were to make a syscall, if you were to go through and instantiate that function's virtual address, like at the beginning, and hold it as a uint32 or a uint64, it will never get garbage collected. Which means that you can basically say, hey, this function's virtual address and everything that you care about it is serialized as a uint32 or a uint64, then here you go. You can basically infer a lot from that. You hold it in memory, you don't have to load a bunch of stuff from disk, and all of these other fun things. So there are tons of ways that there are not tons, but there are several ways you could go through and optimize it, that being one of them. But yes.
Someone had a question in the Twitch chat. Is using WMI still a thing on modern Windows? This provided a great interface into Windows for things like Perl and Python, but maybe defeats the purpose and doesn't feed into the strengths of Go.
Yeah, so that's a really great question. Okay, so for the two in the room and for the folks, I don't have the Twitch chat in front of me, unfortunately. For folks that are not super familiar with Windows, there's something called WMI, which is the Windows Management Interface. WMI is like SQL for Windows. It's trippy. So basically what you can do is with WMI, you can make a SQL-esque call using Windows kind of constructs, and then Windows will say, oh, I know what this is, and then return it back to you as an object. So like, for example, if I wanted to look at all network interfaces, I could say, generically, select star from network interfaces, and then order by whatever. And then WMI would know what the hell to do with that statement, and then it would return it back to me with whatever ordering I have. And it would give me any information about that. So WMI is actually a really powerful way for interfacing with Windows when you need local information about the actual Windows configuration. There is a library by Stack Exchange. It is... I am blanking on that. I think it's Olay. I think it's github.com/stackexchange/go Olay, I think is what it's called. They have a very thin wrapper around WMI where you can make raw WMI queries. The onus is on you to understand what to do with the information that you get back, but last I checked several versions ago, it worked. I wouldn't say that that's inherently a bad way to work with Windows. Or work with Windows in Go, at least from like an operating system configuration standpoint. I would say that that's really kind of up to you as a user. There are several ways that you can pull for information from Windows. Generally, the canonical way to get information is through the registry. However, there is no standard library support for interfacing with the registry, so WMI is a great way to do that. So to take all of that in a nutshell, to answer the original question of should I use WMI in Go and is that a good idea? So long as you are willing to work with the typecasts and type conversions, there's no reason not to, basically.
Is that like a way that the Go compiler could support targeting Windows, or is that just something that like dynamic languages?
No, that's totally dynamic. So think of WMI kind of like SQL, but for Windows. So unless you were to be able to target like the Go runtime as like for SQL, then you wouldn't really be able to target it for WMI. Yeah. WMI is really kind of just an like a querying interface, as opposed to like a management or a syscall interface. COM would be more of like a syscall interface, and you would want to target COM before you target WMI. WMI is something like if I were to write a PowerShell script that does like 10 different things to configure the box, that's what WMI is for. So, any more questions?
No.
Cool. All right, so that's kind of how things work. That concludes that section. So let's talk a little bit about in-flight. And the folks at Microsoft who I have talked with about this are probably going to kill me for that middle bullet point, but I'll explain why. So the first thing that's in flight that everybody who writes Go for Windows is really excited for and just really wants and has wanted since the dawn of time is MSVC support. So MSVC is the Microsoft Visual Compiler. That is Microsoft's proprietary compiler for Windows. It does a bunch of really cool things for C++ and C, and for like Windows specifically. Having MSVC support in Go means that you can now have native CGO support for Windows. That's what that means, and that's big. That is a really big deal because Windows runs on C++ and C and things like that. So like if you really want to build rich applications for Windows, you need that as a minimum, and that's a really big deal. So this change request, the links they're in the slide, they're blue. Feel free to go take a look at them. It's by Caleb Champlin, I think. He is a developer out of Colorado. Who in his spare time has been adding MSVC support to Go. His change request has been open for a while. He's very busy. I would love to help him, but I don't know enough about how Go lays out kind of its compiled binaries. So like elf and dwarf and cough, like I don't know enough about that. I would love to learn more about that. I just don't have the cycles right now because I have like 10 other things going on. But absolutely, if you think it's something that's interesting or something that folks want, please go comment on the discussion. Say, yes, I would love this. Reach out to Caleb. Ask to see if he needs any help. Like, the faster we can get support for this, the better. Like, that means the more that we can do with Go for Windows, like right off the bat. The other one is Windows Store. This technically isn't in flight because it was denied by the Go team, but I had a conversation with some folks at Microsoft, and we might be able to revisit this. So in, we'll say Debian and Ubuntu, just for sake of whatever, you can get everything distributed via apt repositories or snapd or whatever the current tool is. But apt repositories for all intents and purposes. And that's great. That's like the standard way of getting something for Linux. Well, Microsoft, starting in, I think it was Windows 7 or Windows 8, came out with the Microsoft Store, which is their distribution model for applications for Windows. So like, for example, it's very much kind of like iTunes, the App Store. So if you wanted something for Mac that you wanted from like a trusted provider, you go to the App Store, download it. Very similar way for Microsoft, for Windows. And the Windows Store, or the Microsoft Store, is shared between Xbox and Windows. So for example, I got a Fitbit scale the other day. I installed the application on my Windows desktop to go through and set it up, and then when I logged into my Xbox later that night, my Xbox was like, oh hey, you installed this app, and there's an Xbox version of it, which makes no sense at all, but you installed it, I'm gonna install it too, and I got the Fitbit app installed on my Xbox, which, weird, but whatever. So that's Microsoft's way of distributing software. So now you can actually get Python from the Microsoft Store. It's open source Python, it's not changed in any way, but like it is a way to get a safe and tested version of Python for Windows, and Microsoft supports it. And Microsoft said, hey, we'd like to do the same thing for Go. And the Go team was like, no. And Microsoft's like, but we did all the work for you. And the Go team was like, no. And so when I had this conversation with the Microsoft team, I was like, look, I want to revive this. Like, even if the Go team isn't going to support it, like me as an individual, I am more than happy to partner with you, the Microsoft community team, to go through and have this be a supported way of distributing Go for Windows. Do you want to know why? Because I would love to just have automatic updates for Go for Windows, and I really don't actually give a shit about chocolaty. Chocolaty for Windows is great. It's a package manager for Windows. If you don't use Windows, don't worry about it. But like, I would love to be able to get a certified distribution of Go from the Microsoft Store, so then I can just go through and like manage the lifecycle through there and get it through there and all these other things. And then there is Project Athens. I'm assuming everybody has most likely heard of Athens. If you haven't, it is a Go module proxy. This actually came out of the Azure Kubernetes team, which is located here in Boulder. So the Project Athens started out of the Microsoft Boulder office right down the street as Go module proxy support to make their development experiences better. They open sourced it for everybody. I've played with it. Looks great. If I have a use for it, I'll probably use it for cloud.gov, things like that. So those are some of the things that are in flight with Microsoft specifically and Microsoft-based technologies. I have bugged the MSVC team and the SDK team to death about adding MSVC support, and they just don't get it. They don't get the importance of Go as an up-and-coming system language and why it's important to have good Windows support for it. So that one's been like, that's Microsoft technology. The other two are run by Microsoft. So looking forward at the future, there are really kind of two interesting aspects. The first is COM support. I'm still going back and forth with some kernel devs at Microsoft on whether or not like COM support is actually interesting. And I'm also going back and forth with some of the Go folks at Microsoft to see if COM support is interesting. I personally think COM support for Go is very useful, and kind of to Jason's point, it's a way that we could do Go on Windows better. Because then you're working with something that's a little more native to Windows as opposed to anything else. There are some challenges that come with COM support. For example, Go is a procedural language. However, COM is classful. So how do you describe a class in Go? So, and then the other aspect that's kind of future looking, and I've had this discussion with several folks at Microsoft, is, hey, what if we had a CLR backend for Go? So instead of like go build Windows AMD 64, it's go build sysclr. Is that interesting? Is it even useful? So, and one of the things that's really interesting about, so for those of you that don't know, CLR stands for Common Language Runtime. The Common Language Runtime is a standard that Microsoft came up with and then have built tools around. Very similar to COM, but for higher order applications. So the reason that C# and F# and VB.NET and like all these other languages have like total interop, like why I can call F# objects in C# and C# classes in F#, is because of the CLR, right? It's basically a kind of standard of laying out a language in a total interop way. Having CLR support in Go, or having Go be able to compile to CLR-IL, intermediate language, would mean that I could go through and have like my total like front end MVC logic in .NET, .NET Core, whatever that's going to be, and then I can take that and then I can interface with those libraries and those methods and things like that in Go. So if I wanted to have my front end in C#, like my web API or whatever, and I wanted to use Go as like my back-end system language for whatever my use cases are, then I could have full interop between Go and C# or Go and F# or whatever that's going to look like. And so I think it's really interesting to talk about, but nobody's really come to, myself included, has really come to the conclusion of if Go were to actually be able to compile to IL for the CLR, would anybody actually use it, right? So that's kind of some of the future-looking stuff. And that's kind of all I have. I did gloss over a lot of really deep and important things, and probably some acronyms here and there that I know that I just don't think about. Are there any questions from folks in the room or folks on the stream?
Yeah, I don't see any questions.
What don't you like about chocolaty?
What I don't like about chocolaty is that Microsoft has a great way of distributing programs, applications, etc. But it's got a very similar process that like the App Store has. So the App Store for Mac has, you have to pay for it. Like I think it's like $100 up front, and then like you have to jump through these like the certification hoops and a couple other things. And so it's like it's a hassle. Like I'm not gonna say it's not.
Distribute on it.
Right, if you want to distribute on it. And so as part of that, they have Chocolaty, which is like the command line package manager. And I'm not a huge fan of the way that Chocolaty goes about things. Like, yes, it is semi-free and that like there's some basic stuff that's free. But in order to really get like the full features of Chocolaty, you have to go through and pay for it, when all those things you could do with the Microsoft Store instead. So it's really like I just like single channel distribution as opposed to multi-channel distribution because I'm super lazy. Because the Windows or the Microsoft Store will go through and update everything for me, and I don't really care. Like for example, Redis. I really am only using Redis for like local development testing, and most of the time I'm not version locked. If I am version locked, I'm not going to use anything else. Like I'm going to be very specific. I'll use a Docker container or whatever. And so like then that'll be different. But like I just need Redis for development. I want it to auto update. No, I don't want to go through and brew update or Chocolaty or Choco update or all the. I just want it to just update, please. Right? And so that's why I don't like Chocolaty. So now, granted, the paid versions can go through and do some of that, but then you got to pay for it. And at that point, it's the same price as if you just paid for the distribution license for Windows. So, any questions?
I mean, it seems like there's a lot of layers to go through. You had mentioned like Docker. It's just kind of interesting, right? So I'm going to be one of the reasons I'm attending this is because I'm working with a Windows team that's going to be doing a lot of work on Kubernetes.
Yeah, I know that team. So let's talk. Actually, that's a really great. Mind if we kind of segue to that?
Mm-hmm.
Okay, I don't know how we are for time.
Yeah, we're good.
Okay, so let's talk about it. So containers on Windows. Containers on Windows exist in a totally different way and format as they do on Linux, for a lot of reasons. One, it's Windows and Windows works differently. Two, there's no C group construct, right? So I can't really dive into like the low level specifics just because of lots of paperwork, and I really don't feel like getting sued by Microsoft. The general premise is what happens with Windows Server containers under the hood is basically it uses a bunch of native Windows constructs, and then it just bubbles it up through what's called HCS, Hosted Compute Service. And Hosted Compute Service is just a couple different function calls. It's kind of like a CRUD interface, and then you just pass it a JSON payload, and then it'll figure out what to do with it behind the scenes. So the really sucky part about working with containers on Windows is there's only two ways you can do it. You can either work through the Go library or through the .NET library. And the Go library is not that great in the same way that the .NET library also isn't that great. It's a really unfortunate reality. Some of what's going on right now with Containerd is really going to help with that. And I've seen ruminations on the Kubernetes side that Microsoft is going to have a more formalized Containerd interface for actually working with Windows Server containers, so that you are interfacing with Containerd, not HCS. HCS is a pain in the ass. It is not a lot of fun. And then if there's also, is it HCN, Hosted Compute Networking? There's the network provider for containers for Windows is horrible. There is like 4 function calls for it. And then you have to know what JSON to magically pass it. No, by the way, it's not really all that well documented. So unfortunately, like writing for containers with Go on Windows is really not that great. And I'm sorry, but it's just better to know this up front. The team that does WinC, the Cloud Foundry team, and that does it, mostly a bunch of pivots, but they have done a lot of work on working with containers on Windows. I would very much recommend going back and looking through some of the work that they've done. Talk with Matt Horan about it. He helped spearhead a lot of that initial work. And then Natalie Aranello? I can't pronounce her last. I've never really pronounced her last. I'm sorry, Natalie, but talk to Matt and Natalie. They're going to be probably the best place to start for like not only a little bit of history around it, but also like the best way to be successful with containers on Windows. So
yeah, the situation that Warren's team is dealing with now is that we have like a program that's implemented in C that runs in this Docker container, and it's meant for Linux.
Yep.
Yeah.
It's an ELF binary, and everything's meant for Linux. And we have customers that want to run that on Windows Kubernetes hosts. So
did they not know that you can't run Linux workloads on Windows and vice versa?
They want us to build. They want us to package containers that can run on.
So I'm gonna let you in on a secret. It's called the Windows Subsystem for Linux.
yeah, that's what I was telling Warren about, and I was saying, well, you can run it, but then I think you mentioned that the Docker daemon can either do Linux-based
With a virtual machine
yeah,
or Windows.
or Windows, but it can't do both.
The Docker daemon cannot.
Yeah.
There's no reason you can't do both. The Docker's daemon cannot. So for something like that, which is actually a really interesting use case, you can either leverage the Windows subsystem for Linux and run it with a job object, which basically says with a job object. And this is what they did in the early days of the Windows support for Cloud Foundry. It was called Ironframe, I think is what it was called. Talk to Matt and Natalie; they'll tell you all about it. But basically, what you would do is you instantiate a job object and you set the limits on the job object, and then you can kind of like work within that. But you can leverage the Windows subsystem for Linux to run like Linux workloads on Windows, and it works great. Like if you guys are curious, I can demo it after the fact. It is Linux for all intents and purposes, just no kernel. There's like, I think at this point there's like 13 or 14 syscalls that don't work, but they are very rarely used, and there's very legitimate reasons why they don't work. But anyways, so what you can always do is you can technically do a diff of installing the Windows subsystem for Linux and figure out like exactly what libraries it needs and things like that, or you can just do a debugging session and it will tell you. And then you could dump that in a Windows Server container. But the problem is the Windows Server containers don't contain two really important aspects. One, they only contain generally nt.dll, which is like the Windows kind of like library. Nothing works without NTDLL. Like .NET doesn't work, Go doesn't work. Like nothing works. That's what actually is like the interface for the hardware.
Is that like libc for like?
Yeah, it's NT.dll is libc but for Windows.
You're saying that's not available in the Windows?
It is not. That is the only thing that is available in the Windows Server containers, guaranteed. The rest of it is not likely there. So, for example, with WSL, there are a couple other DLLs that it will load to make sure that everything works and does what it needs. Like one of those that it needs right now is Session Manager, depending on like what you're trying to do with it. So, and the Windows Server containers don't ship with Session Manager. Well, great. So technically you could probably run WSL in a Windows Server container, but the amount of hassle required to get there is extensive. That being said, if you're doing it in the open source, come talk to me because I will work with you on that because that is actually quite interesting. But the point is that is how you could do it. Otherwise, you can tell them to go pound sand, basically.
Yeah. I mean, it seems like it's not a well-paved path at this point, so maybe
That's just
we should shy away from doing it at all.
So I have a phrase that I really need trademarked, and I call it a very bad thing.
Yeah.
That is a very bad thing. Don't do that.
Yeah. Run your Linux containers on Linux.
Yes, there's nothing wrong with running Linux. Like Windows is great for all the reasons that Windows is great, and Linux is great for all the reasons that Linux is great. Like don't shy away from either. Use each for its appropriate use case. That'd be like saying, hey, I would love to run Active Directory on Linux. No. Or Exchange or anything like that. So, yeah, that's kind of my talk. Hopefully the subtitles turn out quite well. I haven't really been watching them.
There were a few that were bit humorous. That's what I was saying earlier. So yeah, thanks everyone for joining us on the live stream. Thank you for your questions and all the folks at DTC. Thank you, Mike, for giving that presentation tonight. So yeah, that's about it. There's free food in the back over there if anyone wants any. That's
Is
about
the GopherCon Europe, is that tickets for that closed yet?
GopherCon EU, I believe tickets are still open for that.
So we should, I don't know if our code still works, but if anybody wants that code, they need to contact either you or me so that they can get that, because we can't distribute it publicly.
Yeah, so we have a discount code for GopherCon EU. If anyone's attending or wants to attend, we definitely have a code for that, but you have to contact us directly.
And I will get you the PowerPoint subtitle provider.
Oh yeah, that's really cool. Cool. All right, see you guys
Later.